Hi, and welcome to a practical guide to deploying Zero Trust Network Access. My name is Scott Erickson. I work on the technical marketing team here at Ivanti. I was part of the Pulse Secure acquisition. I started my career in computer engineering from the University of Dayton here in the United States. I have an MBA from Ohio State, over 15 years of experience in mobile, security, and cloud solutions. My background is in software development, sales, marketing, competitive analysis, and product training. My current area of focus is the Ivanti Zero Trust Solution, Ivanti Neurons for Zero Trust Access. A brief overview of what we're going to look at today. First, we're going to give a solution overview of the NZTA solution, and then I'll give a demo that walks through a handful of different sections of the ZTA product. So let's get into NZTA. Ivanti NZTA places the controller in the cloud to reimagine network access to apps. It's not a replacement for VPN, but it helps to extend secure access to the many applications people access without going through corporate network firewalls. It provides granular access and visibility, which I will demonstrate further into the presentation. ZTA is a hybrid and SaaS solution with flexibility to fit your technical use cases. Some of the advantages of the solution that can help are eliminate the inside-outside distinction. Fragmented policy islands can be removed. You permit hybrid deployments, easier consumption, and the hollowing out of the DMZ. So for end users, ZTA provides a consistent experience. They don't have to know the different access methods for different resources like engineering environments or Salesforce. All are accessed in the same way. And as the admin deploys new applications or moves applications, the end user will not be impacted in any way. Their workflow stays the same. For the administrator, it's an easy deployment. You can provide all the resources in a basic end user portal. While the user can view and launch applications from the portal, that's not a requirement. Users can use thick clients or go directly to the web browser, go to the resource in the web browser, including SSO-enabled applications. You get granular policy management. So each resource can have its own policy, depending on the user's device posture, location, time of day, device and application attributes. When the posture changes, access is automatically updated. It can be added or removed. Then the admin can have insights into the policy compliance through a robust system of analytics and reporting. You also get a reduced attack surface. The deployed gateways, while they exist on the public internet, they will behave like a basic firewall. They carry a default deny posture. The gateway will only respond to an end user's access request after an MTLS handshake is completed. This means that only the NZTA provisioned and authenticated devices will be able to access the gateways. Here we can view a basic deployment structure of the NZTA solution. The controller sits in the cloud, managing all policies and authentication traffic. The controller may have some authentication mechanism to an external account management system used for authentication and onboarding. This is the control plane. This includes connection brokers that monitor the device posture for analytics and device compliance. The controller maintains connectivity to all the gateways, as well, again, for policy management. Lastly, the connections for resource access that originate on the end user's device will always go directly to the needed gateway. This is done automatically for the end user. They don't need to know what gateways exist or where they're deployed. The control plane communication ensures the endpoint will always have the updated current deployment state for all resource access. So a couple points on why customers choose Ivanti Neurons. So ZTA allows admins to deploy resources across any type of hosted environment, be it on-prem data center, SaaS, or one of the many types of public cloud providers. The gateways are hidden from public view, reducing the attack surface of deployed resources. And each resource can carry its own unique access policy, dynamically deployed and evaluated. The admin can easily deploy or move gateways and applications without changing the end user workflow. ZTA gives a central point of control for policy and visibility for all resource access. This includes behavioral analytics, which we'll dig deeper into during the demo. Lastly, licensing is simple and flexible, allowing the admin to easily and quickly adjust the deployment as needed. And finally, we recommend taking a few steps. Segment the network based on apps, app domains, and minimizing the lateral data transfers. Deploy gateways for each segment. Policies, controls, and processes may or may not be in place. We recommend becoming as granular and specific as possible for device, user, and data access. Only grant access if the conditions are met. Integrate with other operations and security solutions. SIEM for event correlation, anomaly detection to precisely pinpoint the events, and Ivanti Neurons for healing to automatically resolve device compliance issues or deny access. This concludes the overview, and now let's take a deeper look into the ZTA solution. This demo will cover a couple different aspects to the Zero Trust platform. First, we're going to take a look at the administrative console, looking at items like deployment configuration, insights, as well as the common deployment steps, authentication servers, gateways, items for SAML integrations, and then lastly, the end user workflow, the onboarding process, and the basic details about how an end user will actually use the ZTA deployed machine. The individual demo sections will be insights, visibility, anomalies, administrative tasks, integrations, and then the end user workflow. So first, we're going to jump into the administrative console. So here we're in on the main dashboard, and we're going to take a look at insights. So there are a couple different ways to view the different insights available through the ZTA platform. The main dashboard will show you the high-level gateway application user flows, show you what applications are being used, what users are using them from where. You can look at individual gateways to see different items like critical issues and the individual login associated with that. If you would jump into any one of these different graphs, it will give you the raw data associated with that, so you can view all and see the individual events that make up that graph. To get a better view of exactly what's going on. You can get into each individual user through that. So you have a very deep aspect to the data where you can jump in and actually see not just the overall view, but get into the individual items that do make up the individual data items that do make up that graph. If we go back to the main dash, you will be able to see a separate view. So here we have a graphical view that shows the world and the different gateways that exist. But you can also change this to what's called a Sankey chart and get more of a flow. So you have your user groups, your devices, your gateways, your applications, and it shows you based on volume, really what the flow is of that data associated, so you can get a more logical view rather than a geographic view. Next, we'll take a look at the user dashboard. So the user dashboard is very important because it will show you different things like anomalies, risk factors, and stuff like that. And this is important because this is one of the key functionalities of a ZTA deployment. It's the ability to monitor end users and not just see what they're doing, but be aware automatically when an end user is going out of their normal bit of operation. So something like geographic changes or a end user's account being used from two locations at the same time, or all of a sudden a user is being leveraged in the middle of the night from a different area of the world. These types of accesses are red flags, and depending on exactly what's going on and the severity of it, the user will get a risk score. So you can see different users by risk, anywhere from, in this graph, 5 to 8. So these are the different users that are creating different anomalies that may be of interest to the administrator. Depending on the anomaly, it may just raise a red flag, or it could instantaneously cause that end user to be kicked off the network, depending on what it is. This also includes items like non-compliances. Non-compliances are rules that are set for device posture. So the idea that a device must be of a certain posture, meaning it needs to have antivirus, anti-spyware installed, updated, running. It needs to be corporate owned. It needs to be on a specific network, et cetera, et cetera. There are many different rules associated with these types of ideas that enable you to really have the compliance. There are many different rules associated with these compliances to enable you to ensure device posture is exactly what it needs to be. And the last item here would be application visibility. And the admin has the ability to set up a default gateway that will catch all application access that is not defined by a resource policy. And this would give the administrator the ability to see what other resources are being accessed through their network by their end users. So this would be resources that are being accessed outside of policy. Any application that is set up through a resource policy will not show here. And so, those are known to the admin. They've created policies for them. They've permitted users to access them. But this gives them a good view of what else might be being used, whether it's a corporate application that they may need to create a policy for, or some other external application, shadow IT, items like that. So that's the insight, visibility, and anomalies sections. Next, we're going to take a look at administrative tasks. So if we look at the gateways, you'll see from a high view, we have a couple different gateways set up, and you can see that one of them is running an older version. The most common task that an administrator will take through this console is going to be the upgrade of a gateway. So we look at this gateway itself. This is running the old version, 21.3. This was released in March. And you can see I have the ability to upgrade this to the most recent version. This upgrade would be done in the background. It's suggested that you either schedule it for off hours or have some type of gateway group so that individual gateways can be upgraded without blocking resource access by allowing at least one gateway to be accessible through that gateway group at all times. But that is the main item that administrators will take. There are many other activities that they could do. Rebooting the gateway, replacing the gateway, snapshots. Those are less common but still important tasks. And then also items like enterprise integrations, the ability to integrate syslog servers, the ability to add in trusted CAs, server CAs for use with the ZTA platform. Through clients or client authentication. And then you have the ability to do items like geofencing the IP of administrators so that only your known administrators on your personal network may access this, or you can do it by location or address range. Next, we're going to take a look at integrations and policies. So first, we have a couple different points of integration. We'll look at the user authentication first. And so the ability here for the administrator is to integrate additional IAMs or IDPs, the ability to allow ZTA to leverage some external user database for authentication, for onboarding, for administrative access, stuff like that. Here we just have local, but if you look, the ability to add, we'll do external server, do a SAML custom, log out. So here we have a basic SAML integration. So the admin would go to that external server, pull that metadata file off, upload it here. ZTA will then process that and create a return file, and then the admin would take that return file to that external IAM service or IDP, and then upload it there to create the SAML loop. So fairly standard SAML integration, and it does ensure that pretty much any corporate IDP or IAM service can be leveraged here through basic SAML integration. Next, we'll take a look at the applications. So the administrator can define different applications, and these applications are often some type of basic resource, whether it's a common HTTPS resource or some other server-side resource like an RDP session or a terminal service or SSH or something like that. You can define those resources here. New application. We're just going to do a basic HTTPS application. Define some kind of icon. And then you can see, given a description, you do also have SAML integration here. Obviously, this is slightly different SAML integration than what we just looked at for IAM integration. You have the ability to do SAML integrated SSO. So any resource that has the ability to do a SAML integration, you could do the same type of basic metadata file linking here through this to permit SSO. In that instance, the end user, as they go to that resource, if they're connected to ZTA, they will automatically, that resource will automatically reach out to the defined ZTA deployment and get that user, get that session, automatically log that user in and take them into that resource without them logging in separately. It is a fairly standard basic type of SSO. You can do key value attribute value pairs for any type of user mapping or something like that. So you do have some more configuration abilities with that. As you move through this process, you would then create the application and then define a couple other aspects to this application, the gateway that it is associated with, and then the application group that it is part of. As you see here, this application group Salesforce, you have multiple resources associated with a single resource. So in some instances, you cannot distill a full resource deployment down to a single URL. It may be multiple resource locations that do exist. And so ZTA will need multiple resource definitions for that. After you define that resource, you can then define a policy that is used to permit access to that resource. That would be a secure access policy. So a secure access policy is the ability to define what device posture is required to access this individual resource. Here we have some basic ones: semantic AV low, semantic AV high. These are some pre-built basic policies that are defined, but the admin does have the ability to integrate much more complicated policies with each individual resource. The idea here is that each resource has its own secure access policy, and so end users, depending on their device posture and changes in their device posture, may gain or lose access to specific resources based on the sensitivity of those individual resources. So as a admin adds different severities, different levels of access, the end user may change exactly what they have access to based on what their device looks like, what state it's in, where they're at, what they're doing, items like that. So if we look at the basic policies, you can see some basic AV policies that are defined, but as an administrator, you can define much more than just those basic policies. As we look at the policies, you can add additional policies. Inside there, you have additional rules to add. And these are the individual rules that will be leveraged to define the device posture of that user and device. Here you can see spyware, file, location, firewall, MAC address. There are a number of different policies, number of different rules associated with these different policies. And each one has its own custom set of settings. Here, OS version, Windows, which exact Windows version are you permitting, and then you can choose to allow that, ignore that, whatever it may be. And then these rules, we do offer APIs that are available to add to these rules. So the ones you see in the drop downs here are not the only rules that can be defined. There are APIs available to create much more complex rules and additional rules not shown here in the UI. Next, we're going to take a look at the end user's workflow. All right, so what we're looking at here is a unregistered device, and we're going to walk through the onboarding of this device and explain why it's important to onboard and what happens during that onboarding phase. So ZTA is a endpoint-initiated ZTA type deployment, which means that the device itself needs to be onboarded into the deployment to receive a certificate that will define its device to the gateways, and then that will also tie an end user to that individual device. So there is a device user connection, and that does require a certificate to be installed on the specific device that is connecting. So we are going to walk through a handful of different standard dialogues. If you're familiar with the Pulse onboarding of a standard Pulse client, this is very much the same, except in this we are installing a certificate as well as the standard host profiles that you would expect in a PCS deployment. All right, now that the Pulse client is downloaded and installed, we can log into the ZTA controller. And here we will now have the ability to view the end user dashboard that will show us all the applications that are available for access. That doesn't mean that the end user has to do this. They don't have to use the dashboard, but it is a good point for education and to show your end users what they have access to, or as you add new applications, it will show them what has been added to the deployment recently. So here we take a look at the individual end user dashboard, and for SSO, we can take a look at using Salesforce. So as you see, when I open the link, it asks me to log in through the ZTA SSO. And so as you see, once I click the link, it opened up Salesforce SSO and automatically logged me into the correct account. This process doesn't have to be used. They don't have to go through the dashboard. They can go through a thick client or directly to a web browser to any other resource that may be accessible through ZTA. This is just one way to show them what they have access to. All right, and that concludes the demo today. We took a look at insights and visibilities, talked about anomalies, showed the basic administrative tasks and integrations, and then looked through the different end user workflows. Thank you and have a good day.